GPT-5.4 has come out recently, and you've probably seen a ton of reviews. Everyone agrees, including me, that it's pretty good. But there's some specific things that I haven't really seen a lot of people talk about that I've found in my experiences with it recently that are just super cool. It feels for the first time like we have an incredibly good software engineering coworker, and I just really want to cover exactly why I think that, how I figured that out. We can start here with the article, and you can see it's designed for professional work. I definitely agree with that. It's in ChatGPT. There's 5.4 Pro. Let's go check the benchmarks. Better at Sweetbench, OSRoll verified, Toolathon. Browser use is actually a very interesting thing, and I might make a separate video about that. You've seen all the benchmarks and stats probably from other videos, and if you haven't, recommend Ben Davis's video or Theo's video or Mickey's video. Go give those a look. But it's the perfect coworker. Now, I kind of want to frame this differently. I want to talk about some of my aha moments that have come with LLMs. And the first is probably most obviously ChatGPT. ChatGPT was not necessarily a great coworker, but was a great weird dude to talk to, if that makes sense. He was very smart, sometimes a little bit sporadic and spastic, couldn't count the R's and strawberries very well, but seemed to know quite a lot and was, especially when GPT-4 came out, it was great to ask programming questions too. You could really feel that like something was building here, but it wasn't quite there yet. The next thing was Cursor, and Cursor wasn't necessarily a coworker so much as just a great way to use LLMs. I've been using Cursor since before they had moved to the VS Code fork or acquired SuperMaven or become the insane massive company that they are today. And the thing that they've done the best is just really capture the vision of programming software with LLMs. Every time that a model's come out, they've made it usable. Cursor is like the most usable way to take an LLM and use it for software engineering, but it wasn't quite a coworker either, just more a great extension of myself that I really like. Now, for most people, I think they jump to Claude Code as their like next aha experience. But there's a moment in between Cursor and Claude Code that really struck me, which was T3 Chat and O4 Mini. You might be asking, well, T3 Chat is like ChatGPT, it's just a wrapper, and O4 Mini is, a one of the early series of reasoning models. It wasn't exactly the thing that everyone liked chatting with. Why did it strike you so much? It hit this niche of being something that was really good at setting up infrastructure and setting up computers for you, doing a lot of like really grindy work that would usually require me going into a lot of documentation, reading it, understanding it, grokking it, then taking all of that information back to the task that I was doing, and then setting it all up and doing that task. It was just really, really great. And I think this was because OpenAI just really nailed reasoning, and T3 Chat was just a really pleasant experience. The task that I was doing at the time was setting up headless browser infrastructure. And SST, if you're not familiar, was the way that I did it. It allows you to do things like it's basically a way that you can configure your own version of Vercel on top of AWS's infrastructure. So Vercel is like super optimized for web applications. It's got Vercel functions, it's got the CDN. But if you wanted to set up your own infrastructure for your own niche, SST is the way to do that. And so I use SST to set up headless browser infrastructure on AWS ECS, and I had to use specific load balancing stuff because headless browsers have a bunch of specific requirements around how you set up webhooks. It was a whole thing, but what I would usually do is just copy this config that I have into T3 Chat, say, hey, here's the exact things that I need to do. Can you help me figure out how to do it? Take that, paste it back into this file, then run SST dev, and see the result. And the iteration loop there was just so much easier because it was able to catch all these small, subtle details that would usually be such a grind for me to figure out. And so reasoning models and O4 in general were just fun to chat with because it was like a coworker who maybe wasn't the most pleasant person to talk to, but just worked really hard. It was like the 10x engineer, except they were always on, like they were always in the corner with their headphones on and could only communicate through Slack. Now, Claude Code is what I think has been the aha moment, Claude Code or OpenClaw, for working with an LLM and giving it a lot of access to something, especially your computer, to do work. It's been the thing that people have realized that they can do a lot of knowledge work with. It hasn't exactly struck me, but it's really caught the hearts of a lot of people. But Claude Code tends to be something that does a lot of assuming for you, and that assuming can often be correct, but for some things it isn't. And I found that using Claude Code for things like the headless browser infrastructure that I was setting up can, for the most part, be pleasant, but is sometimes not as pleasant. But now we have 5.4 and Codex, and it feels like the perfect, smart, intelligent coworker that you can really do anything with. And it will probably replace a lot of not necessarily knowledge workers, but the engineers that people would hire at companies. And I'll explain why. When you're hiring someone, let's move this to the side, you're usually looking for a few things. So let's put down hiring requirements. And this is for engineers. There's like a few kind of like principles that everyone follows. Number one is that, especially this is like a piece of advice that's often repeated in the Bay Area, you hire for spikes. And what a spike is a particular area that you're better at than most people, the thing that you really excel at. And as a founder of a company, you're usually trying to fit all of these spikes together so that you can, build a product and achieve PMF and IPO eventually. But you want to hire someone who is better at something than anyone else. And then there are things like communication and responsiveness and enthusiasm, or we'll say eagerness. These are things that I found personally, especially in the Bay Area, that people love to hire for. They want to hire people who are hungry, who really want to go after it, who really want to work hard, and just bring the entire workplace up. And let's say three is that you want to hire for people who can generally zoom in and out of things. So they're able to hold like a lot of context in their head at once. This isn't a requirement for everyone, but I think it's a requirement more and more as the kind of like as the nature of our work is becoming increasingly higher level. So generally, okay, we've had employees or we've had a lot of people that you can hire at companies that fit a few of these requirements. Maybe they're spiky and they can hold a lot of context in their head, but they're not necessarily like very communicative or responsive or eager. Maybe they can hold a lot of context in their head and they're communicative and responsive and eager, like a product manager, but they're not necessarily spiky in engineering. But now you have an LLM, and with an LLM and a good harness, you can create the employee of your dreams. You can have it have the exact spec that you want for the exact tasks that you need to get done. And let me explain how. If we go and look at the Codex system prompt, and we won't cover as much of the harness because the harness experience is important, but the prompt is the thing I really want to kind of dig into. You can see that they've kind of baked in this personality into Codex. So you can see that the default personality is concise and direct and friendly. You communicate efficiently, keeping the user informed about ongoing actions without unnecessary detail. Prioritize actionable guidance, state your assumptions, all that fun stuff. You can see responsiveness. Codex has a feature called preamble messages where while it's doing tasks, it gives an explanation about what it's about to do, why it's going to do it. You can see here that it has some stuff on planning, how it's like able to keep track of what stuff it's going to do, which for this explanation is less important. It adds some stuff on task execution. There's a really fun line in here that I like where it says, do not attempt to fix unrelated bugs or broken tests. It's not your responsibility to fix them. You may mention them to the user in your final message though. One thing that OpenAI does better for their kind of like tools is letting the user have a lot of choice. I find that Claude Code sometimes assumes too much for you, but as you can see here, like they really want you to define how things work. And then it has a section on validating your work. So as you can see here, Codex is already like, if you were to define a bunch of requirements for hiring someone, you'd have something very similar to the Codex system prompt. But what you can do is, and everyone has seen this, is have an agent around the specific employee that you want, because agent really operate as like extensions to system prompts. I don't think many people have realized this. So if I want an employee who's really, really good at doing this new task that I decided to get 5.4 to do, which is set up K2.5 inference on SF compute, I just kind of write an agent file and chuck it at the problem and it does it because the models are truly agentic. They I don't need to give it a guide on how to do things and say, do A, do B, do C, and then assume that it has the smarts to be able to do those things well. I can actually just give it a lot of space to do a task and have a lot of confidence that it will get it done. And that to me is just really fascinating that we've gone from the era of, okay, like I'm going to go into Cursor and do a task to, okay, the model is helping me do the task and it's way smarter than me, but it can't actually do the task to, okay, the model is pretty smart and can do the task, but it doesn't necessarily have like a lot of guidance or maybe just like doesn't assume the same things or have the same taste that I do to 5.4 on Codex, which is just it has the same taste that I do. It has the exact spike that I would want for someone who needs to get this task done, and I can have almost as many of them as I want. I could run 5 different threads on this. Like I can hire 5 of the same excellent person if I wanted to. That's truly, truly incredible. Let me talk a little bit more about like how I figured this out and what task I gave it. Like I said earlier, I was working on Key 2.5 inference on SF Compute. Now, it's not a task that's incredibly technically complex. It's really just very grindy. You just kind of need it to go discover all these weird edge cases and things and set up this computer properly. And it's really good at that. So as I was working on this, originally I started with 5.3 codecs. I had this like Cloud Init YAML that I had it generate. And so there's a bunch of like packages and scripts and kind of general things for the environment. But I didn't quite get it to work without grinding through figuring out that the default version of CUDA on the SF Compute node was different than the one that Kimi K2.5 needed because of the specific VLL, just all of the tedious details that go into deploying something like this. So when I had enough experience to kind of describe the activity that I was going to do, I made this agent.smd file. I said, okay, here's the goal of the project. I want to get this model running. I want to get it running on this specific service with this specific feature of the service. Here's a Cloud Init file that like kind of has a bunch of setup stuff. Here's exactly how SF Compute uses it. Again, doing more of the environment describing versus task describing. Here's kind of like what happens. Here's some edge cases that are really painful. If you do a redeploy, it wipes the node's files. The Cloud Init does a bunch of specific stuff. By the end of this, I wanted it to use Tailscale serve so that my local machine could ping the SF Compute node, and instead of like hosting a web server, I could just do it through that. And then I gave it some more details, like the end goal of this is curl the machine through Tailscale, ask it to run hello world. It has SSH access. I gave it some specific instructions to do things that I personally like doing when I'm doing this kind of development. So, hey, make sure you use T so that when you run a command, it automatically pipes all the logs to a file and it makes the file a little bit easier to read. I think I asked it to use tmux in here, and it did at some point. But yeah, so I just gave it this agent.md file. Then I just kind of asked it to solve the problem until it was running, and it did. But that's not even the coolest part. We haven't even gone to one of 5.4's amazing tricks that you really want a coworker to have, which is steering. Steering is like tapping your coworker on the shoulder and being able to chat with them and ask questions and have them be able to shift what they're doing in response to that conversation you have. A lot of the reason why work is going back in person is that this experience has been missing. It's been hard to like ping a coworker on Slack and okay, now you have to wait because they might be away from their computer or they're focused on some specific thing. You can't get their like that experience has been missing. And when you work with LLMs, that experience also feels like it's missing. If you set up a Ralph loop, you're kind of hoping it does the right thing. You hope that you can adjust it, but it doesn't exactly like make sure that it's staying on the right track with the right task. But you have that here with 5.4. It's genuinely, genuinely incredible. And I'll give you an example of it. So I asked it to start solving this task. I kind of like, this is my first year, which is duplicated because of a weird codex thing where they don't, anyway. I say, hey, like, I started the SF compute server, but you need to redeploy it. And so it says, okay, like, I have the default image. The only time I really canceled, this is like one of 2 cancellations, was just me seeing that I was about to spend money. And I was like, please don't do that because I don't want you to have full access to that. And so I gave it all the permissions and then I just kind of let it go. And as it was going, I was kind of sitting around thinking of stuff to do in the background, reading Twitter because that's what you do. And then I realized I was like, oh wait, I ran into this problem where I run out of like it takes a long time to download the model weights, and I want to try this new service called Archill. Shout out Archill, so that I have a network disk, and it's a lot easier to get the model weights next time. And so as you can see, it starts doing a bunch of stuff, and I tap my coworker on the shoulder. I'm like, hey, one, can you make the Hugging Face download a lot faster? And two, can you like implement this new service? I like in the background went and set it up for you, so it should be good now. This was a steering prompt. I didn't stop it. I didn't spin up a subagent. I didn't spin up another codex instance. This was a steer. And what it proceeded to do was say first, okay, can I access this networked drive that we've mounted? And then it goes and it kind of like figures out that, okay, like looks like I can mount it, but I can't read and write from it. And so I had to give it some more information, and don't worry about that key being there because I deleted it. And so eventually, okay, it figures out how to mount the token. And it does a few things. First, it tries to just start downloading the Hugging Face model directly to the disk. And it does this in the foreground. So it says, okay, great. I'm checking if it's downloaded. And looks like we've got some stuff in there. And so it looks like the persistent disk path is like working and I can download stuff. And one really interesting thing is that it has like a great sense of time. Like you can see here, I say, hey, I said in the agents MD, like, make sure you watch a bit for time. And it says here, the reservation still ends at 5 p.m. PST, and it's currently 4:23. This path is working, and the next risk is just time. So if you want to finish this in one pass, extend the node window. And I was like, oh, that's good. So I extended it, and it double checked it. You can't really see the tool calls because it says this is a day afterwards. And then it keeps driving on this task in the foreground. It says, hey, okay, I'm going to compact. VLM is still loading the model, but it kind of runs into an issue. But then it decides, hey, the fastest path for this to get done, right, because it's almost half a terabyte, is to probably download it onto the main SSD that's attached to these GPUs, and then we'll like transfer it afterwards. So what it does is that it does that task, and then at some point, if I scroll way down here, it starts VLLM. You can see it starts running into those errors here. And in the background, it starts syncing all the data, all the weights that we've downloaded to the Archill disk. I didn't ask it to do any of that, by the way. It just decided that that was the best use of its time. That is truly incredible. Like, this is what I mean by 5.4 is a coworker. It's not just, you know, a model that's like using its harness to get things done because you asked it to. It's, you know, not something that like kind of understands and is kind of grasping for stuff to do like Claude Code. It's like it is truly working through stuff like a like truly competent employee would, but it's an employee that you had a hand in shaping, that you built the spike for. And I just think that's like truly, like it's truly awesome that we've gotten to this point where, yeah, the models are like just like they're like better software engineers, or they're like very competent at these like grindy tasks, which I think is very interesting. You can even see here that I like ask some prompts about like, hey, does this have a factor in it? And it says no. It gives me some very direct answers about why not. It gives me some very direct things that it's going to try. And then it says, hey, if this run fails, then I'll spend some time trying to like do that. It does a bunch more work on this. And then eventually, one other thing that I found very helpful, and this is like a last tip before we wrap up, is I did stop it once just so that I could ask it to be a little bit more thorough in terms of solving the problem. It's not that it wasn't thorough before, but I just wanted to make sure that it like was a lot better at validating the things that it was working on, and it just like went and completed this task pretty much perfectly. And then I asked it to like do some stuff like write down a file, and you can see here in the final message, here's the Archill status. The sync is not active. I haven't finished this task of updating the cloud init.yaml, which eventually we got done, but throughout this entire agent trajectory, it had a good understanding of how much time it had to complete a task, had a good understanding of of what it was trying to do. Even through compactions, it kept track of you know what were the last steps that it tried. It's just like it works super, super well. So if you focus on just updating your agents MD properly, you focus on like building a good system prompt. If you're building your own custom harness, you can really create your own custom like employee or person or agent or whatever that goes and does stuff for you. And 5.4 is very, very good. It's like truly, like it's a step function better in a lot of ways. And I think that we'll see more people talk about this and feel this in the future as they get familiar with their tools. So anyway, what do you think about the model and all that? Add comments, and I'll see you in the next video. That will probably happen in a year. Okay, goodbye.